Hello people, everybody, welcome back. Okay, so today what we're doing is, we're doing a math video today, everybody. That's what it is. We're doing a math video. So, I don't know, if you know me well, you may know that I know a whole lot about math. I do, it's true. I've been told for longer than I've had a YouTube channel that I should make math videos. I've been always hesitant because I understand that I know this stuff well, right? And I don't know how to explain it all the time, right? This is a personal opinion of mine, but math teaching is very... Can we calm these cars down? I think that math teaching is very important. My dad was a math teacher. Math teaching makes or breaks somebody's liking for math. That's what I'm getting at. I don't know, I guess I've been nervous to breach this. I don't love my new haircut. It's a little short, but I got it for graduation just so I could all look like, I look like a non-gender alien walking up there. I'll put a picture of it on screen. But, I don't know how accessible it is. I don't know how entertaining it is. I don't know what I need to explain. I don't know if it's going to be lost on everybody. But listen, today we're going to take a crack at it. So the background here is I took a 400 level linear algebra class. I am a math major, and the grade was broken up into the homeworks, the exams, and then a project, right? And so, we were supposed to pick a project, and I didn't really pick a project. He was like, pick something on this list, and I was like, I don't really care about any of the things on this list. I wrote him something, but I didn't really I didn't even submit a project proposal. It was how does this relate to computer science? And I don't care. You know what I mean? I like math for math. It's just fun because it's fun. You got to do it for the love of the game. Okay, quantum computing is cool, but I didn't ask about quantum computing. I asked about linear algebra. I asked about math, okay? So you know what I'm saying? Stochastic matrices, those are kind of fun. But anyway, we're getting off topic. So I was, I didn't even have a topic proposal because I was I don't know. And then he showed tensor products on screen. And I knew exactly what I wanted to do. So today we're going to talk about tensor products and a very specific type of tensor products. Or if other people who know these things want to help out with this, it might be kind of a fun community project or whatever. But I found a very special type of tensor. I don't really know what the implications of it are. I just know that it's a fun little thing you can do. So with that, I guess we'll get started, huh? So let's see here. We really need to get our ducks in a row. I should start with this simpler example before I talk about what we're talking about today, which is, this is what's going on. There's algebra, and there's linear algebra. So algebra, which is 3x plus 1 equals 4, okay, and then x equals 1 would make that statement true. 3 times 1 plus 1 equals 4. True. Okay, so that's algebra. Now, there's linear algebra, which is a system of equations. So it's okay. And then it's a little bit more work, but you would see that, what would it be? X equals 1, y equals 2. And then you plug these numbers in, and these are true statements. And then yay. You can see that a true fact is true. So that's algebra, and that's linear algebra. And then the difference in linear algebra is instead of one equation, you're doing a system of equations. Then another way to write this now is a matrix. So look, we have 3x plus y, 1x plus 2y. So you could write just 3, 1, 1, 2. And then you could write it x, y. So I'm showing you this to talk about, this is how you would multiply this out. Top number goes with the first column. The second number goes with the second column. Like that. And then we said that equals 5 and 5, which we would write as 5 and 5. So, okay, I'll put timestamps up because if you know what's happening, then we can cut to it. So this is how well, actually, no, I'm doing fine. Just, how about you guys let me keep going? Let me talk, okay? You know what I'm saying? Is that all making sense to you? So what I've just explained to you is called matrix multiplication. So, and that's a matrix in a vector. So these are vectors. This xy is a vector, 5, 5 is a vector. And then they're not equal. Because they're next to each other, they're not equal. Those are two vectors. So then you'd get we're getting a, x, equals, say, y. Okay. And then, so that's like a fun little equation. All right. So that's how you do that, whatever. And then, and then you have matrix, and then you can multiply a matrix by a matrix. So you can go like A times B equals like, and then you'd have like 1, 2, 3, 4, and then say X, Y, Z. Okay. And then the way you multiply matrices like this row times this column, okay, is going to give you, you're going to get a new matrix from this. So a matrix times a vector equals a vector, but a matrix times a matrix equals a matrix. It's like how an even number times an odd number is still an even number. No, that's not the same at all. Don't worry about it. But a matrix times a matrix still gives you a matrix. All right, so this multiplication that we're talking about right now is going to give you this entry. It's a 2 by 2 matrix. These are 2 by 2s. So see how it's like there are 4 entries. See how that equals 4. But there are 2 rows and there are 2 columns. 2 columns. See, and then you multiply the rows by columns and you get 4. It's very archaic, but it's nice if you think about it. But so that's kind of what's going on there. We got the rows, we got the columns. It's just 2 by 2. So 2 by 2 is this is gonna give us a 4 by 4. So let's finish this off here. Actually, we don't have room, so let's redo this A times B here. So this is gonna be like W plus 2y, and then X plus 2z, and then we have 3W plus 4y, 3x plus 4z, if that makes sense. So basically, you have this and that equal this. You have this and this equaling this. Okay, and then we've got this and this equaling that. That and that equaling that. Is that like 3D? I kind of killed it with the colors there, did I not? That's fun. Cool. Well, okay, so we understand matrix multiplication. Oh, this is going to get complicated, everybody. Okay. All right.